All right, class, let's look at 22.5 as we talk about earthquakes. And we have alluded to earthquakes already, but let's dive into this in a little more detail. Basically, and when an earthquake occurs, it's due to the movement of our Earth's surface, due to the movement of those plates, and specifically because there's been pressure that's been building up and that pressure is released. Okay? So the Earth's surface, that movement, when there's a sudden shift and releasing a bunch of stored energy, then you're going to get an earthquake. And that sudden shifts sends waves through our Earth's crust. Vibrations, they call them seismic waves. And remember, we talked about S waves and P waves. Okay? Pressure waves and the seismic waves here, the S waves. S waves, I think, were up and down or left and right. The pressure was back and forth, back and forth. If the waves happen in a large body of water, that can create a large wave, a large movement of water. We know that is called a tsunami. Okay? So here's the idea. You need to know that at different places where the boundaries meet, if there is shifting of these plates, and specifically if they're shifting in a way that when they're rubbing against each other, if they're catching and they're continuing to increase in pressure and pressure and pressure because they want to keep moving but they can't because they're stuck against each other, and then all of a sudden the pressure is too great and they have to move, and that stress then is released, well, and when that tectonic plate finally does move, and then they're going to release all of that pressure and buildup of energy and release it in the form of a wave, an earthquake. So tectonic plates move, they cause stress in the crust, and that turns into faults and folds, like as you can see here. A fault basically is a break in the mass of rock along which movement occurs. And a fold is kind of the same idea. It's just a bend in the layers of rocks, again, because of the tremendous stress and pressure that is occurring due to these plates colliding into each other. Okay? So how does that earthquake occur again? It's going to occur because you've got these two. Okay, let's talk a little bit about, we know that how the earthquakes are going to occur and how they're going to be produced because of that stress and the buildup of that potential energy that is finally relieved, and then a wave is going to be created. You should know that the focus is where the earthquake starts. The epicenter is right above that focus on the Earth's surface. They're related in that the focus is going to happen underground. The epicenter is on the surface right above the focus. Okay? Now, here's something really cool is we're going to talk about some physics because this relates to physics, and we're going to be doing physics later on. But the physics of the earthquake is that you have all of this rubbing and stress and release, and it is going to cause tremendous energy in the form of waves to be emanating through the Earth's surface, the Earth's crust. Okay? You have, as we've mentioned, P waves, primary waves. These are longitudinal waves. What it means is that particles get pushed together and then they get stretched out. And then they get pushed together and then they get stretched out. And then they get pushed together and then they get stretched out. This is kind of like cars in traffic. This is also how sound waves are created. So if you push them together, and then they're going to push the next one and the next one and the next one, and originally they're going to get compressed, and then they're going to push against each other and stretch out, and then they're going to get compressed again, and then they're going to push against each other and stretch out, and then they're going to get compressed again. That is a pressure wave, or P wave, also called a primary wave, because they travel fastest and they get to another location first. They are the fastest seismic waves. Okay? And they can travel through solid and liquid. You should know that. Then you have S waves. There's our S waves because secondary, and they are more like ocean waves. So they travel up and down or right or left. So S waves are secondary. They are slower, and they travel in a different method. They travel just a little bit different pattern. They are called transverse waves. Okay? So you need to know that there are S waves and there are P waves. S waves cannot travel through liquids, so they will not penetrate and go through the Earth's core. All right? Obviously, you have surface waves on the Earth's crust. That is a little bit of like a ripple in the Earth's crust when you have an earthquake. And these surface waves move more slowly than P waves and S waves. Okay? Those are the ones that are doing great damage because they come and they produce a lot of movement. Even though they're moving slowly, they create a lot of movement in the crust. And anything that is on the surface then is going to get affected. Okay? Kind of a rolling motion on the Earth's surface. That's what's doing a lot of the damage. In order to measure the magnitude of an earthquake, we have different scales, but the one that you probably are familiar with is the Richter scale. And to measure earthquakes and pinpoint their epicenters, they use seismic waves. They use these waves, they detect these waves using instruments. And then how they detect them, where they detect them, the strength of the waves helps them then come back to the location where they originated. Okay? A Richter scale is basically a logarithmic scale, which basically means it's a power of 10. So if you have 1 on the Richter scale and then 2, this is actually not just a step of 1, it's actually 10 times more. Anytime you go up by 1 on the Richter scale, it's 10 times. Okay? I'm not going to ask you about these different scales. Just be aware mostly of the Richter scale. Okay? When an earthquake happens and these P waves and S waves are transmitted everywhere through the Earth's surface, notice how they travel. These S waves travel like an ocean wave, and notice that they do not penetrate through the Earth's core. But the P waves go directly through the core and other layers of the Earth, and they are pressure waves. They do get changed in direction a little bit as they go through the liquid, but still they can reach all the way to the other side of the Earth. Okay? These earthquakes are happening, as we mentioned, along plate boundaries. Why? Because that's where the different boundaries or where the different plates are rubbing against each other. Along these faults and along these different areas where the different portions of our Earth's surface are interacting, where they're meeting, where they're rubbing against each other. Okay? All right. That's basically the idea of what you need to know from this section. Really short and sweet, to the point. Just make sure you understand this information about earthquakes.